Hello, hello. So the next worksheet that you're looking at is some factoring review. I'm going to do some of these with you so that we can kind of make sure that we remember how they work. Most of these are pretty straightforward. These ones down here are things that you've probably forgotten, sums and differences of cubes. Those go away pretty quick. These here, sometimes you've got some factor by grouping, sometimes you've got some of these that are in quadratic form, and we want to make sure that we're factoring completely. Then we look at solving by factoring, and then we actually look at some long division just to make sure we remember how to do this stuff. These are all things that may or may not end up being on your final, so we want to make sure that you are ready to go for them. So let's have a look. I'm going to do just a couple from the first section. Let's go ahead and look at this one first so that we can kind of remember how to do these. So I've got x squared plus 2x minus 8 equals 0. These ones for 1 through 8, they just want you to factor it. They don't want you to solve it even though it's equal to 0. So let's look at this and see how we can factor it. Remember, we've got two different methods. The one that you used last year was the area model. So I'm going to start with that one just so we can make sure we're in good shape here. And we start by putting our x squared here, our minus 8 here. And then we multiply these things together. So I've got a negative 8x squared. And then this 2x is what goes down here. Remember, this is my product, this is my sum, and I need to figure out the two numbers that will fill in that diamond problem. So I need two numbers that multiply to give me a negative 8. So one of them is going to be a positive, one of them is going to be a negative. And they have a sum of a positive 2. Because they're opposite signs, I'm looking kind of for a difference of 2. And so with 8, I've got 4 times 2. So I've got a 4x and a 2x. Notice that this way I've got a positive 4 and a negative 2 gives me a positive. If I switch my signs, I'd end up with a negative. Okay? So then I just put these in here. Remember, it does not matter where they go. And then I just need to solve my area model. I can take an x out here and an x out here. Because I've taken out an x, I need a 4 here, and then I need a negative 2 here. So I get x plus 4 and an x minus 2. Okay? The other way that we can do this, and this is the way that I've really been pushing for you to just be able to think about these, right, is that kind of guess and check and just being able to recognize what's going to go where. Here, I've got an x squared, so I know I have to have an x and an x. This is a negative 8, right? So I know in order to get a negative 8, I have to have a plus and a minus because I have to have a positive and negative in order to get a negative for my product. Now with 8, we can list our factor pairs. We've got 1 and 8 and 2 and 4. I'm looking for a difference of 2, and so I know that I'm going to have a 4 and a 2 and then check to make sure it works. So I've got a negative 2x, a positive 4x gives me a positive 2. Okay? Let's look at one more. Let's look at x squared minus 8x plus 15 equals 0. Okay. This one I'm just going to do with kind of that quick method. Remember, these tools are great tools to help you if you're stuck. Sometimes the tools are more cumbersome than what you need, so we want to try and build that fluency. Remember, that's our overall goal, is to get to the point where we can just look at it and we can just factor it. Right? 15, it's positive, right? That means that my signs are the same because my sum is negative. I know that they're both negative. And in order to get 15, it's either 1 and 15 or 3 and 5. And it ends up being 3 and 5 because negative 3x and negative 5x gives me negative 8x. Okay? So those first ones should be pretty quick. The next one that we're going to look at, The next one that we're going to look at is the sum and difference of cubes. Right, sums and differences of cubes, we have those two formulas where if I've got a cubed plus b cubed, right, we know that that's going to factor into an a plus b. It mirrors this one. I've got a squared, my second one squared, my first one squared, and then my sign changes, and then I multiply my a and my b together, and then plus my last one squared. Remember that it's the exact same thing, but with a different sign for a difference of cubes. That's what makes these easy to remember, because you really only have to memorize one, even though they're, two different formulas. So for a difference of cubes, it mirrors what's there, right? A plus B is what I can take out. And then I've got my first one squared. Instead of being a negative here, it's going to be a positive, right? It's the opposite of whatever that sign is. AB, and then it's always going to be plus a B squared. Okay? So let's look and see how these can play out. Let's say I've got 27x squared minus 64. Okay, this is x cubed, not squared. It's got to be cubed if I want to do a difference of cubes, right? So for this one, I'm going to rewrite this as something cubed minus something cubed. That can really help us figure out what my A is and what my B is, and then to use the formula. So this is going to be 3x cubed, right? Because 3 cubed is 27 and x cubed is x cubed. And then 64 is 4 cubed. So now I've got my A and my B. I know that my first factor is going to just be a 3x minus 4. It just mirrors what's right there. And then I've got my 3x squared, so that's 9x squared. Then it's going to be plus this times this, so plus 12x. And then plus my last one squared, which is 16. And that's it. I don't have anything else I need to do there. Okay? Let's look at another one. Which one do we want to look at? Oh, let's look at number 12, because that one's kind of tricky. At least it looks like it's tricky, but it's not. Number 12 says 16x cubed minus 54. And if you look at this, you kind of think initially, oh, those are not perfect cubes. I don't have something cubed minus something cubed. But if we're going to be factoring completely, remember that's going to be the goal, factoring completely, getting everything factored down as much as we can, the very first thing that we look for is what? Greatest common factor, right? I want to take out that greatest common factor because that's going to make it so that I can easily see what it's made of. In this case, I can take out a 2, right? So I've got 2 times, I've got 8x cubed, keep writing x squared, minus 27. Now in here, do I have something cubed minus something cubed? You bet I do. So I've got 2 times, this is 2x cubed minus 3 cubed. And so remember, I can't forget about this 2 that's out in front of here. Remember, when I'm factoring, I can't divide away my greatest common factor. Instead, I can pull it out to the side. So I've got 2 times, I have it mirror this first one. Then I take my first one squared, and then I multiply these together, and it's going to be opposite this sign. So it's going to be plus 6x, and then I've got plus 9. Okay? Let's look at some of these other ones. Let's look at factor by grouping. I like these. So 12r cubed plus 18r squared plus 16r plus 9. So remember, with factoring by grouping, you've got 4 terms. And remember, at the level that we're at, they're always going to be ready for you. They're going to be given to you in a way that you can factor them by grouping. So if I'm looking at this, I can take out the greatest common factor of my first 2 and the greatest common factor of my second 2. So looking at this, oh, it's not 16R, it's 6R. I was going to say that's not going to work. Okay, it's just a 6R, not 16. So here I can take out a 6R squared. If I take out a 6R squared, then I'm going to be left with a 2R plus 3. Right? If I multiply this back out, I'm going to get a 12r cubed, and then I'm going to get an 18r squared. Out of this one, I can take out a 3, and so then I'm going to have a 2r plus 3. And now I can factor this 2r plus 3 out. So I've got a 6r squared plus 3 times 2r plus 3. And now we have to decide, are we done? Is there anything else that can continue to factor? And that's when I look at this one. Can I take a 3 out of both of those terms? I think I can. So 3 times 2r squared plus 1, and then I've got my 2r plus 3. So that one is now factored completely. Okay, another one that we'll look at is when we've got the quadratic form. So let's say I've got x to the 4th minus 2x squared minus 24. And so for this one, remember, I could use factoring by substitution, which we looked at that before, or we can just realize that I'm going to separate it out and I'm going to have an x squared and an x squared, right? It still is that quadratic form, except for instead of having an x and an x here, in order to get an x squared, I've got x squared, x squared. That's going to give me my x to the 4th, and then when I multiply it by numbers, then it's going to give me that x squared in the middle. My signs are going to be opposite, just like they were when we were looking at it with regular factoring. It doesn't matter that they've got a 4th power instead. We're still going to factor it the same way. That's what makes these kind of fun. So I have a product of 24, and I have a difference of 2. So that's going to be a 6 and a 4, right? And then my difference is a negative 2, so that means that my bigger one has to be negative, minus 6 plus 4. Okay? Now I'm going to do this one again, but I'm going to change my signs around. Say I had a plus 2x squared minus 24, right? It still is going to factor with the same numbers, but my signs are going to be different, right? Instead of having a plus 4, it's going to be a minus 4 and then a plus 6. Now with this one, the reason why I'm changing it is because if we want to be factoring completely, we want to look at this piece right here. And for this one, I can continue to factor this, right? This is a difference of squares. So I know it's going to factor to an x plus 2, x minus 2, and then an x squared plus 6. That piece still stays with it. So if you're factoring completely, you need to look at the end and say, did I factor this out all the way, or is there anything else that I can take out of there? Okay? Solving by factoring, that's pretty basic. If I've got 2a squared equals negative 42 minus 20a, if I want to solve by factoring, first thing, get everything on the other side. So 2a squared minus 20a, plus 20a, plus 42 equals 0. I can divide both sides by 2 to make it easier for me to factor, because I have an equation and not just an expression. Right? If we looked at this one, there's no equation here, so I can't divide both sides by 2 and make that 2 disappear. So I had to have that 2 out in front, right? With this one, I can't do that. I could just keep it out in front, but I don't necessarily have to, because I can divide both sides by 2. Because I can take 0 divided by 2, it's just a 0. So here I can just cancel a 2 out of everything. So I've got a squared plus 10a plus 21 is equal to 0. All that it does is make my factoring a lot easier, right? So 21 is 7 and 3. They do add to 10. So I've got a plus 7, a plus 3. And then what's that property that we're going to use that lets us figure out, because it's a product that equals 0? 0 product property, right? 0 product property. That really, really helpful one. So if I've got a product where things are equal to 0, I know the parts are both equal to 0. So a is equal to negative 7 and a is equal to negative 3. Okay, that's all that I'm going to show for those ones, because they're pretty simple and straightforward. You've looked at those so many times, and not very long ago either, with looking at parabolas and stuff. So next, I know you guys love long division, right? Long division, synthetic division, you guys love dividing polynomials. It's one of the things that you love to do more than anything, right? Right? No? Okay. Well, we're going to do it anyways. We have to remember how to do this, because this is an important skill for especially those of you moving on to pre-calc. So I'm going to do a couple of the problems that you've been given so that you can get a practice with them. And there's 2 different ways that we're going to do it. The first way that I'm going to do it is with synthetic. Remember, this is a review, not a reteaching. So you might need to go back and look at your other notes if what I'm giving you is not quite enough. But I'm going to take it slow and go over it again as I go. So hopefully it will be. So this is problem 29 from your worksheet. So I've got 4r squared minus 2r minus 19 is being divided by r plus 2. So if I'm looking at this, if I remember with synthetic, we had r minus c, right? So we ended up taking the opposite of whatever that number was. And remember, we set up our synthetic division like this. We took our coefficients, 4, -2, -19. We took the opposite of this number and put it here. This is going to be a -2. And then we started off, the process is we brought this down, and then we multiplied. So I had a -2 times 4 gives me a -8. And then we add as we go down. So that's a -10, right? And then I'm going to multiply again. So -2 times -10 gives me 20. Adding these up, I get a +1. Okay? Now remember, this is the coefficient of my answer. If this was an r squared, then this is going to be just an r. We take 1 away from what was there. So I've got a 4r minus 10, and then my remainder gets added on, but it's divided by my r plus 2. Okay? I'm going to do one more of these synthetic division ones for you. Or hopefully with you, right? You're doing this along with me, not just me doing it for you, hopefully. So I've got 2k squared, this is number 32, minus 9k minus 55 divided by k minus 8. So remember, we start off by taking these are my coefficients, remembering to take my pieces there with them, my signs. And then it's always the opposite of what's here. This is k minus 8, so I have a +8 right here. My first number comes down, and then I multiply. So I've got 16. 16 minus 9 is going to be a +7, right? Remember, because we add, paying attention to our signs. 8 times 7 is 56, and so then I get a +1, right? Always adding, paying attention to our signs. So I've got a 2k plus 7 plus 1 over k minus 8. Okay? So that's your synthetic division. The next piece is long division. And you do need to do both of these on here, mainly because if I have something like number 33, 45b squared minus 72b plus 3, and that's divided by 5b minus 8, there's something different going on here. This is not of the form r minus c, right? I have a coefficient in front of my r, or in front of my x, right? Whatever the variable I'm dealing with, in this case it would be b, right? I have a 5 there. So if I wanted to divide this out using synthetic division, I'd have to change it into this form, and I would end up with b minus 8/5. So that means that 8/5 is the number that would go here, and now you've got fractions. And I have a feeling most of you probably don't want to deal with that. Long division is a longer way to do it, but when you're dealing with something where it's just going to be more cumbersome in terms of arithmetic, it's a lot easier to just use the long division. So that's what I'm going to do here. And that's what I suggest you do for the last 4. All right. So I'm going to be using that long division process and just working my way through. Remember, I have to figure out, how do I change a 5b into a 45b squared? Well, I multiply it by 9b, right? My goal is to make it match completely, so then I have to distribute it through. I've got 45b squared minus, that's a 72b. And remember, as I'm going through, I'm going to subtract. So as I subtract, I have to change my signs, right? I change my signs as I go because I'm going to be subtracting it as we go down. In this case, I actually get a 0 and then a +3. It's not going to go in at all anymore. There's no way for me to change a 5b into a 3. So my remainder is just going to be 3. So I've got 9b plus 3 all over 5b minus 8. This one looked like it was going to be kind of big and cumbersome, but it actually ended up being pretty darn quick, huh? In that case, I'll do one more. Let's look at, I'll do 36 with you because that one's long, and I do not want you to get intimidated. So 8x cubed plus 64x squared plus 136x plus 82, and that whole thing is going to be divided by an 8x plus 8. Ooh, my 8's in a weird spot there. That doesn't look right. There we go. There's a lot of 8's. Okay, so for this one, we're going to start off, how do I turn 8x into 8x cubed? What do I need to multiply it by? I've already got my 8, so I just need to multiply it by an x squared. So I'm going to end up with an 8x cubed plus 8x squared. And remember, I change my sign, right? Change your sign because you're subtracting as you go down. So those cancel out, and then I end up with a just a positive 56 x squared. And then I'm going to bring down my 136. How do I change an 8x into a 56x squared? Well, I've got to multiply it by a 7x. And then I have to distribute it through here, right? So I'm going to end up with a 56x squared plus 56x. Once again, change your signs and subtract as you go down, right? And so this ends up being, is that 86? No. Yes? No, it's just 80. 80x, and then plus 82, bringing down my last piece. 8x goes into 80 how many times? 10. Distribute it through, so I've got 80x plus 80. Once again, change your signs, right? Change your signs as you're subtracting, so I end up with a remainder of 2. So remember, as we're listing out our answer, 8x, x squared plus 7x plus 10, and then plus 2 all over 8x plus 8. Okay? So this is that factoring review worksheet. Hopefully that's enough to get you through it. And remember, I'm uploading my worked out answers too. And if you need any help, let me know. Thank you and see you soon.